All right, boys and girls, welcome to lesson 4. On page 12 is bell work. Page 12 in your notes is bell work. So complete page 12, pause the video, complete page 12, and then when you're finished, I'll show you the answers. Okay, welcome back. Hopefully you have done page 12 by now, and I'm going to display the answers. If you have any questions on any of these, please be sure to send me a text and remind, and I will answer your questions. So the biggest thing to remember is, like on the first one, both circles are closed, so that's why our domain is 1, 7 in brackets. But in the third one, both circles are open, and that's why our domain is parenthesis -2, 4. If you're struggling with adding the fractions like 2/3 and 6, I am completely fine with you doing that on your calculator. So if you have any questions about these, please send me a remind. Okay, so hopefully everyone has the answers, and we're going to move on to the lesson. So again, the notes start on page 12. And our objective today is that we're going to graph a piecewise function. And you may be asking, what is a piecewise function? A piecewise function is a function broken into pieces by the domain. We use piecewise functions in several places in the real world. For instance, if you are mailing a package, there may be one rate for the package if it's between 2 and 4 ounces, and there may be another rate if the package is between 10 and 12 ounces. And that would be considered, and we would represent that with a piecewise function. Another example is that you may rent a car, and for the first few miles, you're charged one rate, miles per hour, and then after a certain number of days, you may be charged a different rate for miles per hour. So those are some of the places where you might see a piecewise function. In this example, I'm showing you examples of graphs of piecewise functions. Notice in this first example, it is broken into 3 pieces, and it is not continuous. In the second graph, it's broken again into 3 different pieces, but this time it's continuous. And then the last example, it is still broken into 3 different pieces, and it is not continuous. A piecewise function can have infinite number of pieces. The ones we do in this class will generally be between 2 and 3 pieces. And in this unit, we are only doing linear functions. Okay, so let's do this first example, and all we're doing is just graphing. So I want you to see that this function is this has 2 pieces. The first piece is what happens when x is less than -2. The second piece happens when x is greater than or equal to -2. Notice they're both linear, so we're going to use what we know about linear functions to graph these. I'm going to start by using the endpoint. So x is less than -2 is the endpoint of this first piece. So we always want to start with our endpoint. So I'm going to just simply do an XY table, insert -2, and so I have -2 plus 5 is -3. So we're going to start off with that first order pair, which is -2 plus 5 is +3. I knew that. So this, we're going to go to -2 and 3 and put our first dot. Now, we can do another part of that graph. We need a number less than -2. What's the number less than -2? -3. So then we have -3 plus 5, which is 2. So then we have -3 and +2. So -3 and +2. And it's good to get at least one other point. We know this is linear. We know that this has a slope of 1. So I'm just going to go down 1 and to the left 1. By going down and to the left, that makes it a positive move because I'm doing 2 negatives. And I don't have to continue what's the word? Calculating points. That's the word I'm looking for. I don't have to continue calculating points. I can just use the slope to finish the graph. Now, because it's less than -2, not less than or equal to, there's going to be an open circle at -2, 3. And continue. Okay? Now we're going to do the second part of that graph. So to do the second graph, I have to, again, start at the endpoint. So I'm going to do x, y, and I'm going to start at -2. When x is -2, what is this graph? It's going to be -4. When x, I need a point greater than -2, so I'm going to try -1 because that's greater than -2. And what is it going to be? It's always going to be -4. This is like saying y equals 4, which has a slope of 0. It's a horizontal line at 4. So I'm going to start at -2, 1. I'm sorry, -2, 4. -2, -4. And I'm going to put a closed circle. And because it's a horizontal line, I just can draw my horizontal line. Okay? Let's try another example. Again, we have two linear functions. And again, all the problems that we're doing today are linear. So we have two linear functions, and they're defined by when x is greater than or equal to 1, we have -2x plus 3. When x is less than 1, we have 2x plus 1. So once again, we're going to start on the endpoints, which is 1. And I'm going to input this into the first graph, 2x plus 1. So that gives me 2 times 1 plus 1, which is 3. If I want to do another point, I'd have to do a point less than 1, which is 0. So then I have 2 times 0 plus 1, which is 1. So I have enough points to go ahead and get started. So I'm going to start on when x is 1, y is 3, and it's an open circle. Then when x is 0, y is 1. My slope is 2, so I notice that I'm going down 2 and to the right 1. And we can just continue that pattern without computing more points. Okay? And then to do the next one, we're going to start at, so this was y equals 2x plus 1. And now we're going to do another chart for -2x plus 3. So where are we going to start? We're going to start on the endpoint, which is 1. So that is -2 times 1 plus 3, which is -2 plus 3, 1. So we have the point 1, 1. If I just wanted to grab another point that's greater than 1, let's try 2. I have -2 times 2 plus 3. That's -4. And so -4 plus 3 is -1. So I'm going to start on x is negative. I'm going to start at 1, 1. This time it's a closed circle because it's greater than or equal to. And my slope is -2. So I'm going to go down 2 and to the right 1, which should give us exactly what we have here, -2, -1. So I keep going down 2 and to the right 1. And I draw my line. And it looks like that. I should have done it in a different color. It's nice to do these in different colors so that it just makes it pretty. Alrighty. How about you pause the video and do problem number 3, and then we'll come back and see if we agree. Okay, welcome back. Okay, welcome back, boys and girls. Let's just quickly do this. Our endpoint is x is less than or equal to 2. So that's going to be our endpoint. We're going to start at 2, and we have -2 times 2 minus 4, which is -4 minus 4, -8. So that order pair is going to be 2, -8. we're going to start at 2, negative 8. It's a closed circle because it's less than or equal to, so it's a closed circle. And then it has a slope of negative 2, so we're going to go up 2 and over 1. And again, we can do a second point. Let's say 0. And if I put in a 0, I get negative 2. 0 times minus 4 is negative 4. I chose 0 because I knew that that was the y-intercept, and so that it should be on negative 4. So up 2 over 1, and then it's a closed circle on that endpoint, so I would just draw the line, put that arrow. Okay, so let's do the next, and let's do it in a different color. And let's start at x is 2. And we have 4 times 2 minus 9, which is 8 minus 9, negative 1. So I have the order pair of 2, negative 1. Again, if I wanted to take a different one, it's greater than 2, so let's take a number greater than 2. Let's take 3. We'll have 4 times 3 minus 9, which is 12 minus 9. 12 minus 9 is 3. So we're going to start at 2, negative 1. X is 2, y is negative 1. That's here, and it's an open circle. And it's got a slope of 4. So that means that we're going to go up 4. 1, 2, 3, 4, and over 1. And we could see that we're at the point 3, 3. And we continue that 1, 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. So that looks like, cricket line, like that. Okay, so that's what you should have gotten when you graph that. Now in this next problem, we have a 3. We have 3 parts. So again, remember, if we have 3 parts, this middle one, we have to take the endpoints of both of those. So let's start at negative 2. Negative 2. And so when x is negative 2, we have negative 2 minus 1 is negative 3. So our first point is negative 2, negative 3. So let's start at negative 2, negative 3. And we have an closed circle because it's less than or equal to. So that's going to be a closed circle. So negative 2, negative 3. We have a slope of 1, and it's positive 1. So we're going to down and over, and we draw a line. Now, again, if I wanted to check my work, I could take a point less than negative 2, say negative 3, and then I have negative 3 minus 1, which is negative 4, and we see that's that point, negative 3, negative 4. Okay, now, to draw the middle one, we're going to have to take 2 points. So our first point is at negative 2. This is a closed circle. We talked about that. So we have negative 2, and putting that into the middle one, we get 2 times negative 2 minus 1, which is negative 4, negative 5. And this would be an open circle. So at negative 2, negative 5, we have an open circle. And then let's do the endpoint, which would be 4. And at 4, we have 2 times 4 minus 1. We get 8, 7. And that would be a closed circle. So this point would be 4, 7. Okay? So we're going to start at negative 2, 5. And we have an open circle. We also know that when x is 0, this should be negative 1. And at 4, it's going to be 7. And it's a closed circle at 7. So our graph should look like this, going through negative 1, which is our y-intercept. Okay, and then for the last part, let's get another color. Green. We have x is greater than 4, so once again we're going to start at 4. So when x is 4, we get 3 times 4, negative 3 times 4 plus 8, which is negative 12 plus 4, which is negative 4. And if we want to take another point, just for good measure, we could take 5, and we would get -3 times 5 plus 8, which is -7. Okay? So we're going to start at x is -4. So we're going to start at 4, -4. 1, 2, 3, 4. And we have an open circle. And then at 5, we're going to be at -7. Should be here. And so what we're saying, we're going to go down 3. 1, 2, 3, and over 1. Down 3, 1, 2, 3, over 1. Just give us a couple of points to make a nice pretty line. Okay, there we go. And that is our next graph. All right, what I'd like for you to do is I'd like for you to do problems 5 and 6 on your own, and then I will come back and I will show you the answers. Okay.